Hi there, welcome back. This is Weblan once again. We are continuing with a revision for the June paper that was written by the grade 11th Eastern Cape, and we are looking at question number 3. The first question here, in question 3, the first part is saying, given that root 13 sine x minus 3 is equal to 0 and x is in the first quadrant, that is between 0 degrees and 90 degrees, without using a calculator and with the aid of a diagram, determine the following. Remember, get the question paper to make sure you see what the questions are saying in full. We need to draw the diagram here. For us to draw the diagram, the first step, we need to rearrange this one. Let's take 3 to the other side. So we have root 13 x is equal to 3. It becomes positive, and then divide by root 13 root 13. So we are saying sine x is equal to 3 over root 13, and then we need to use this to draw the diagram, and this has told us that it is in the first quadrant. Now our diagram in the first quadrant is supposed to be like this, and sine x, remember, it's opposite over hypotenuse. So our 3 here is the opposite, and our x is this angle here, right? And this is a right angled triangle. If this is x, it means this is our opposite. So our opposite is 3, and our hypotenuse is 13. Our hypotenuse is 13, and we need to use Pythagoras theorem to determine the value of x here. You should not forget to do that. So our Pythagoras theorem tells us that the square of this side added to the square of this side is equal to the square of that side, and then put square root to both sides. That is our Pythagoras theorem, but in this case our x will be equal to the square root of root 13 squared minus 3 squared. And when you simplify this, you are going to have root 13 squared remains as 13 minus 9, that is a 4. Square root of 4, it's 2. So we have a 2 here. That is our diagram. And then the first question is saying tan x. Tan x is opposite over adjacent. Tan is opposite over adjacent, right? So we can just write it here. Tan x is opposite over adjacent. That is 3 over 2, right? That is the first one. And then the second one, tan 360 plus x. This one is in the first quadrant. It is in the first quadrant, so it's equal to sine x, and we have already been told that sine x is equal to 3 over root 13. 3 over root 13. And then the next one, cos x squared minus sine x squared. We get cos x and sine x from our diagram, and from our diagram cos x will be equal to adjacent over hypotenuse. So our cos x there is 2 over root 13, and it is squared there, minus sine x, we already have it, that is 3 over root 13, and it's also squared. That's equal to 2 squared there is 4. Root 13 squared is 13 minus 3 squared is a 9 over root 13 squared is 13, and this one gives us negative 5 over 13. And that's how we're supposed to do the very first question. Let's go to the second one. The second one is saying if sine 40 is equal to p, determine the following in terms of p without using a calculator. Without using a calculator, we are supposed to determine sine 220 and cos negative 40. When you meet a question like this, it's best to use a diagram again. It's best to use a diagram, and just remember your p is a p over 1 there. So sine 40 is equal to p over 1, and you draw your diagram in the first quadrant once again, right? Sine is opposite over hypotenuse, so this is 40, the opposite is p, and hypotenuse is 1. And when you use Pythagoras theorem, your x here would be equal to the square root of hypotenuse squared, that is 1 squared minus opposite squared. This is equal to square root of 1 minus p squared. That is our diagram. Now let's deal with what we are given there. Sine 220, we need to reduce that one first. We find it in which quadrant? 220. This is first quadrant. This is 180 minus theta. This is 180 plus theta, and this is 360 minus theta. So this one is in the third quadrant, is 180 plus theta, and our theta here is going to be equal to 40. So it's sine 220 is equal to sine 180 plus 40, and sine is negative in the third quadrant. So when we reduce it, it becomes negative sine 40, and we already know the value of sine 40, that is p, so this is negative p. And the next question, cos negative 40, this one, where do we find it? Which quadrant? This is found in the fourth quadrant, right? Remember, the positive side for when we are measuring degrees, it's anti-clockwise direction. But if we go clockwise direction, that's negative 40 in the fourth quadrant, and our cos in the fourth quadrant is positive. So this one just gives us positive cos 40, positive cos 40, and our cos 40 there is equal to adjacent over hypotenuse, that is 1 minus p squared. That is the answer for that one. Just one thing I had forgotten on your diagram. When this is 40, always remember to write the size of this angle, right? In this case it's 50. Remember, it's 180 degrees, the interior angles of a triangle. So if this is 40, it means this is 50. Some of the questions, when you meet them, they won't even talk about this 40. They will talk about the other angle here. All right. This is question 3.2. And let's go to question 3.3, the one that is more interesting. This is 5 marks. Determine the value of this expression without using a calculator. All right. This is question number 331. 331. All right. This is going to be equal to, starting with this one, this is a co-ratio, sine 90 minus x. It gives us positive cos x, and all over this one. Remember, when we add or subtract 360, it does not change the value or position of that ratio. So cos x minus 180 there. To make it easy for you, you can just say cos 360 plus x minus 180. We just add 360 there. 360 minus 180 is cos this minus that, it's a 180 plus x. So this angle here is in the third quadrant and cos is negative in the third quadrant. So this is negative cos x minus 2 this cos negative x. In the previous question we said is in the fourth quadrant, so it's just cos x, it is positive, so we have a cos x there. And then what do we do next? This is going to be equal to negative cos x minus 2 cos x. It's just a matter of adding these things. So we have cos x over negative 3 cos x. And then we've got common factors there. Cos x, we are left with a 1 here, which is the coefficient there. So it gives us negative 1 over 3. This is 5 marks for this thing. Where are the 5 marks coming from? Let's see. 1 mark for this, and then 1 mark for this negative cos x, and then 1 mark for negative 2 cos x, and then 1 mark for 3 cos x, and then the last mark for this one. And then the next question, is it very long? Okay, it will fit here. We have cos 200. We have a number of special angles there. A number of special angles. Simplify this also without using the calculator. How do we do that? This is going to be equal to, this is question 332, ne? 332. Simplify without using the calculator, starting with cos 200. Cos 200 gives us what? It's in the third quadrant, so it's cos 180 plus 20 over this one is tan 360 plus 45. Remember that time we said when you have an angle which is greater than 360, we can just subtract 360 from there. So it's tan 405 minus 360. Then you are left with tan 45 there, something that is more manageable. And this one we have sine negative 150. Take your negative outside, so we have sine negative 150 there. It becomes negative sine 150, and then 150 is in the second quadrant, is negative sine 180 minus 30 there, which is positive. So we are saying there multiplied by a negative sine 30, right? Negative sine 30. And then the last one is cos 340. That's cos 360 minus 20 there. That's cos 360 minus 20. And then simplifying them, we are going to have, this is third quadrant, so it's negative cos 20 over tan 360 plus 45. We saw that here it's tan 45. Tan 45, and then negative sine 30 there, and this one is the fourth quadrant. Cos is positive there, so it's cos 20. And then simplifying there, we have cos 20 and cos 20 common factors, they cancel each other, and then we have a negative here which is going to cancel with this one, so we are left with 1 over tan 45 times sine 30. These are special angles. You are not supposed to use a calculator, so you use those triangles for special angles. The triangles for special angles, we've got an isosceles triangle there with 1, 1 and root 2. This is 45, 45. This is one of the triangles for special angles. The other one, it has a 60 here and a 30 here. 1, 2 and a root 3. You should know these two little triangles. So tan 45 is opposite of adjacent, so it's equal to, this is 1 over, this one is a 1 multiplied by cos 30, sorry, sine 30 is 1 over 2, so this one gives us a 2. This question was having 5 marks, so let's see where we are getting those 5 marks from. There is 5 marks for, there is a mark for 20, then there is a mark for 45, and then there is a mark for negative 30, there is a mark for this one, and finally there is a mark for simplifying there. That makes it 1, 2, 3, 4, 5. And then the last question in this part. Is it the last question? Not yet. Prove the identity sine theta minus cos theta times sine theta all over cos theta minus in bracket 1 minus sine theta squared is equal to tan theta. Prove the identity. How do you prove the identity? Remember, when proving the identity, we need to prove that the left hand side is equal to the right hand side. So in this case, we choose the left hand side because there is nothing to simplify on the right hand side. All right, what do we do here? The first step, we can factor out a common factor there, that is sine theta. We're left with 1 minus cos theta. And then on the denominator, we can change this cos theta minus Pythagorean identity. This is cos theta squared. And then this is equal to, we need to factor out also on the denominator, sine theta bracket 1 minus cos theta all over, factor out cos theta there, bracket. From here we're left with a 1 minus, from here we're left with a single cos theta. Then we have a common factor again which cancel. We are left with sine theta over cos theta, which is equal to tan theta, and that's equal to the right hand side. We've proved the identity here is equal to the right hand side, and this was only 4 marks. This was only 4 marks. The first mark was coming from here, the second mark was coming from this and the third mark from cancelling there. We are left with this, and the last mark is coming from there. That's 4 marks. This was question number 3.4 with 4 marks. And then the last one. All right. The last question, determine the general solution. Determine the general solution. For the first step, we need to write this in the standard form by taking this to the right. Is 3 over 2 tan theta minus 10 is equal to negative 1,077. And then this fraction has to come this side also. It's 3 over 2. It's a matter of multiplying both sides by 2 over 3 multiply 3 over 2 tan theta minus 10 is equal to minus 1.077. This is multiplied by 2 over 3. This is going to be 3 cancel, 2 cancel. We are left with tan theta minus 10 is equal to negative. When you multiply there, you are left with negative 0.7. Okay, 0.718. This you only deal with it right at the end. You now need to get the reference angle there. Your reference angle will be equal to the second function of tan 0.718. When you are getting the standard form, ignore the negative. You only use the negative later on. So this is 35,68 degrees. That is your reference angle. Now, your negative is the one that tells you which quadrant you should go to now. And tan is positive in the first and third quadrant and negative in the second and fourth quadrant. And then remember, tan is a special one. We don't need to write 2 general solutions for the 2 quadrants. We can just put them together. So let me write from the second quadrant, theta minus 10 is equal to, in the second quadrant is 180 minus 35,68 degrees plus 180k. Instead of writing 360, we write 180 because the 180 is going to help us to alternate between the second and the fourth quadrant. And then theta is going to be equal to 180 plus 10 minus 35,68 plus 180k. And then this simplifies to be 154,32 plus 180k, and our k, remember, is an element of z. This is the general solution for tan. This is only for the second quadrant, right? 154.32 is in the second quadrant. If we add a single 180, it goes to the fourth quadrant. So when k is equal to 0, it's in the first quadrant. When k is equal to 1, it goes to the second quadrant. And then it continues like that. This was question number 3. And for now, we stop here. We are going to come back with question number for in the next video. Enjoy.